Hello and welcome to our talk today regarding absolute spectral irradiance measurement using an integrating sphere and a Lambertian calibrated light source. Presented by Mountain Photonics, member of EPIC and part of the Photonics Plus virtual exhibition and conference. My name is Johannes Dörfler. First of all, I would like to introduce our company named Mountain Photonics. We were founded in 2005, based in Landsberg am Lech, close to Munich. And we are 9 people in total. And Mountain Photonics, first of all, is a distributor for optical metrology, consisting lasers, different kind of light sources, optical measurement systems, mainly spectrometers, optomechanics, and photonic components. But beside that, we are also manufacturer of our own products, which is our Mountain Sources, our Mountain Optics, and our MountainSpheres. And today I would like to talk about our method of measuring spectral irradiance using a MountainSphere. So let's start with the measurement setup. Well, the task is to measure the absolute spectral irradiance in watt per square meter and nanometer at a certain position. And this measurement should be independent of the angle of incidence. So the solution is, of course, using an integrating sphere. Well, this is a method not invented by Mountain Photonics. It's a very usual method of measuring spectral irradiance. And this integrating sphere should be connected to a fiber optical spectrometer. Well, the function is that every single light beam that enters the entrance port of the integrating sphere will be diffusely reflected at the inner wall of the sphere. And that leads us to a very homogeneous distribution of radiance over the entire sphere volume, independent of the angle of incidence. So an acceptance angle of 180 degrees will be accepted by the integrating sphere. So far, this is the measurement setup. Now, with this measurement setup, we are able to measure a raw signal in counts per nanometer, assuming that the spectrometer already has been calibrated for nanometers. But what we are going to measure is an absolute signal in watt per square meter and nanometer. And that's why the whole measurement setup needs to be calibrated for absolute irradiance. And therefore, we are using a calibrated light source. Now, there are different kinds of calibrated light sources for irradiance calibration, but we are using a second integrating sphere with exactly the same dimensions as the measurement sphere. So with the same port diameter and the same sphere diameter. But this time with internal halogen bulbs and a constant current driver. And this gets us what we call a Lambertian radiator, with constant radiance independent of the angular at the exit port of the sphere. And of course we know the absolute spectral irradiance at the exit port of the sphere, so it's a calibrated light source. Well then, the calibration of the measurement setup is pretty easy. The only thing we have to do is to put this light source upside down on top of the measurement sphere, port to port, to get a well-known spectral irradiance at the entrance port of the measurement sphere. And then we have to measure this irradiance with the raw signal of the spectrometer and divide the well-known absolute spectral irradiance by this raw signal. And this gets us the calibration factor in watt per square meter and nanometer divided by counts per nanometer. And to give you a short impression of the MountainSphere, here are a few pictures. So at the first picture on the right side, you can see the actual measurement sphere with the fiber exit, and on the left side, the calibration light source. And the measurement sphere can be mounted on a stand for easy calibration, so you can put the calibration light source on top upside down port to board, and it can be locked by a bayonet lock. So that's it. This was a quick impression of the MountainSpheres, and thank you for your attention, and looking forward to meeting you at the Photonics Plus. So thank you for watching.